Hello and welcome to the Edupedia world. In this tutorial, I'm going to cover the leftover topic from the previous tutorial, that was thread pool. And in addition to covering thread pool, I'll be also covering some of the important Java questions on concurrency control. Since concurrency control is really important topic of Java, that's why I'm also going to take some of the important questions that can be asked to you if you are practicing for any interview or giving any other exam for Java. Okay, so let's begin. So let's study thread pool. Well, you see, what is thread pool? Whereas when we call as thread, so thread means a single thread. If we want to create multiple threads, then we can also create multiple threads. But whenever you create a thread, there is a overhead, okay? Overhead of creating new thread. So what if just imagine a scenario where you created 10 threads and keep them in a pool, and as and when required you just fetch a thread from that pool and utilize it. When the work is done, you may re-enter the same thread again back to the pool. So instead of taking a overhead of creating new thread every time, why not maintain a pool? So well, this is a concept of thread pool, and now let's see how it is done. So you see, this is a implementation. In this implementation, what we are doing is we are having uh, okay, so before this directly jumping to implementation, let's read something about thread pools. Well, thread pools are useful when you need to limit the number of threads when running in your application at the same time. There is a performance overhead associated with starting a new thread, and each thread is allocated some amount of memory for its own stack. Instead of starting a new thread for every task to execute concurrently, a task can be passed to a thread pool. As soon as the pool has any ideal threads, the task is assigned to one of them and executed. Internally, the task is inserted into a blocking queue, which the thread in pools are dequeuing from. When the new task is inserted into the queue, one of the ideal thread will dequeue it successfully and execute it. The rest of the idle thread in the pool will be blocked, waiting for the dequeue task. Thread pools are often used in multi-threaded servers. Each connection arriving at server via network is wrapped as a task passed on to the thread pool. The thread in thread pool will process the request on connections concurrently, and a later trial will get into detail about implementing the multi-threaded servers in Java. Java 5 comes with a built-in thread pool in java.util.concurrent package, so you don't have to implement your own thread pool. You can read more about it in my text on java.util.concurrent executor service. Still, it can be useful to know a bit about implementation of thread pools anyways. Here is a simple thread pool implementation. Please note that this implementation uses my own blocking queue class as explained in my blocking queue tutorial. In real life implementation, you would probably use one of Java's built-in blocking queue instead. Fine. So over here you see we are having public class thread pool, and in that we use private blocking queue task queue equals to null. Fine. Then we are having private list pool threads equals to new array list pool thread. Okay. After that we are having private boolean is stopped equals to false. So over here in the thread pool we have actually created a list of threads, and the type we have given is of pool thread. Okay. Then we are also having blocking queue and stored variable. Then in constructor we are taking number of threads you want to construct and maximum number of tasks. Now the task queue is assigned to new blocking queue. So the blocking queue we have get to the number of tasks. So we have actually created a blocking queue, and then we have created threads in the array list of threads, we are adding new pool of the task queue. So we are actually adding this blocking queue with maximum number of tasks by including number of tasks. So overall, we have actually created a pool for threads. We are actually starting all the threads in our pool thread array list. Fine. This is the execute method of the same class where we are doing task queue, which was blocking queue dot enqueue. Okay. And then we have a stop method where we are doing thread dot do stop. Fine. Then we have pool thread, which is implementing the thread class inside a pool test. Again, we are having a blocking queue and is stopped and having a similar implementation of this. Fine. So this is an example of thread pools. The thread pool implementation consists of two parts: the thread pool class, which is public interface to thread pool, and a pool thread class, which implements thread that execute the task. To execute the task, the method threadpool.execute is called with the runnable implementation as a parameter. The runnable is enqueued into blocking queue internally, waiting to be dequeued. The runnable will be dequeued by an ideal pool thread and is executed. You can see this in threadpool.run method. After execution, the pool thread loops and try to dequeue our task again until stopped. To stop the threadpool method, the threadpool.stop is called. The stop called is noted internally in isStopped member. Then each thread in the pool is stopped by calling doStop on each thread. Notice how the execute method will grow an illegal exception if execute is called after stop has been called. The thread will stop after finishing any task they are currently executing. Notice that this dot interrupt call in pool thread dot do stop. Okay. This makes sure that thread blocked in a wait call the task queue dot dequeue calls break out of the wait call and leaves the dequeue method call with an interrupted exception thrown. The exception thrown is caught in the poolthread.run method, reported, and then isStopped variable is checked. Since isStopped is true, the poolthread.run will exit and thread dies. Okay, so this is how the thread pool will work in Java. This was a simple implementation. I hope you got it. Okay guys, so the last topic of concurrency control we have is to study some of the questions. Okay, so I have already, made a list or even searched on the few particular websites like which all questions are really important. So let's do that. Hello guys, so now we will cover question and answer section for threads and multi-threading. So let's review the questions. So you can see the first question that we have is which says you have a thread T1, T2 and T3. How will you ensure that thread T2 runs after T1 and thread T3 runs after T2? Well, the answer for this question would be that this can be achieved using join method of a thread class. So you see that the join method of a thread class will allow you to do this because it will make sure that when one thread get completed, then only the next thread starts. And this is exactly what we want. So we wanted to ensure that T2 runs once T1 is finished and T3 runs once T2 is finished. So it can be easily done your join method. Fine. So, well, that's what I was, telling. Like join method is the one that will help you. Now let's move to the next question. Okay, so the next question is what is the advantage of new lock interface over synchronized block in Java? You need to implement a high performance cache which allows you multiple reader but a single writer to keep the integrity. How will you implement it? Well, the answer for the second question you can easily find it anywhere on the internet, but I'm just going to give you a brief over here. For the first question, that is the advantage of lock interface over a synchronized block will be that the major advantage A block interface on multi-threaded and concurrent programming is they provide two separate blocks for reading and writing, which enables you to write high-performance data structure like concurrent hash map and conditional blocking. Fine. So this is how it is advantageous over synchronized block. And in order to implement high performance cache, you can implement it using a read write lock, which will allow you to get one write lock at a time, but will allow you to have multiple reader locks. Okay, so this is how you can implement it. Okay guys, so the next question is, what is the difference between wait and sleep method in Java? So the only major difference is wait release the lock on monitor while sleep doesn't release the lock on monitor while waiting. Okay. So you see your wait method does release the lock and sleep does not. And wait is used for inter-thread communication while sleep can be used to introduce a pause even in a single thread of execution. So that's the major difference between wait and sleep. Fine, so let's move forward to the fourth question. Okay, the next question is an important question which says, write a code to solve producer and consumer problem in Java. Now, this is a very well known question and highly asked in interviews as well. So let's go through the answer in detail. So it says producer should wait for the queue or bucket is full and consumer should wait if queue is or bucket is empty. So this is a problem. You see, like producer consumer problem says like producer can keep on producing and consumer can keep on consuming. But the problem occurs when producer is not able to properly wait if the queue or bucket is full. And if the bucket is full, then producer should wait. It cannot keep on producing. And same goes for consumer. It should wait if the queue is empty. So how to solve that? How to ensure that producer does waits when queue is full and consumer does waits when queue is empty? Well, this problem can be implemented or solved by different ways in Java. The classic way is using wait and notify method to communicate between producer and consumer thread and blocking each of them on individual condition like full queue and empty queue. Okay, so these are two of the methods. One is wait and notify method. And then with introduction of blocking queue data structure in Java 5, now it is much simpler because blocking queue provides a control implicit. So let's see like how blocking queue and how wait and notify works. So blocking queue has a method which is put and take that will help you to solve this problem without implicitly implementing wait and notify. So let's see the actual code to resolve the producer and consumer problem. So this is a code in which we are using a blocking queue. So you can see we are having, some of the imports. So we are importing blocking queue, link blocking queue, then obviously this is for logging. So this is our class producer and consumer problem pattern. In this class, we are having a main method. And then we are creating a blocking queue. So blocking queue shared queue equals to new linked blocking queue. So linked blocking queue is our implementation of blocking queue. And we are creating a object which is a shared object that is a blocking queue. Now creating producer and consumer threads. Now let's create two threads. One is a producer thread that we have created and another is a consumer thread. So you see that producer and new consumer. So producer and consumer are the class and we are passing this blocking queue into the constructor of producer as well as consumer while creating the new thread. After that, we are calling start method on producer and consumer thread. Now let's see the implementation of producer and consumer. So this is a producer class. You see the producer class does implement runnable because we are creating a thread, so it should implement runnable for that sake. After that, we can see that we are having its own blocking queue. So the blocking queue that you pass in a constructor, in this way, it is actually shared queue. So it is passed, the same queue is passed to the producer and consumer. Okay, so it is accordingly set according to the constructor. Now this is the run method where we are, producing. So what we are doing is we are actually producing, let's say 10 items. So we are actually printing the value of I. And after that, we are keep on, putting it in a shared queue that we have produced this thing. So it should be placed in the queue. So in this way, it is actually done by, putting it in a queue. So this thing will keep on putting it in a queue. Then let's go to our consumer code. So now consumer also implements runnable and it is also having a constructor which shares the same blocking queue. So the blocking queue will be set through a constructor. After that, you see that we are having a run method of a consumer. So it is consuming while true. And what it is consuming, it is calling shared queue.take method. So from take method, it is keep on taking the things that we have, shared it in a shared queue while producing. And once it's empty, so it's obviously take a pause over there. As soon as the next is available, it start again consuming. And how does it actually work internally? Well, it actually works internally using wait and notify only. But because there is a blocking queue, so you do not need to take care of wait and notify yourself. The blocking queue is taken care of. You just need to use the blocking queue in your code to resolve your producer and consumer problem. Okay. So this is how we resolved it, and this is the output you can see. As soon as we produce 0, 1, so it's consumed 0, and then it waited, then we produced 2, it consumed. So you see, like, firstly the production is done, if you see all of the code, and then its consumption is done. So it's always in a sequence in a way that firstly, whenever the production is at its full, then there will be a pause, and whenever the consumption becomes over, or like all the things that have been produced are actually consumed, then there is a pause in consumption also. So this is how the output will be produced, although it's not like it's not ensured that every time you run this it will give you the same output, but thus it will ensure that your consumption is always done after production of that item, and it does take a pause if there is nothing to consume, and if the queue is full, then the production also take pause. So it will ensure that thing and will not give you any error. Okay, so this is how you does solve your producer and consumer problem. So now let's move forward. Okay, so this is a question which says what is a volatile keyword in Java and how to use it, how it is different from synchronized method in Java. Well, the answer for that is volatile keyword in Java is used as an indicator for Java compiler and thread that do not cache the value of a variable and always read it from main memory. So you see in a volatile keyword, it is used as an indicator to tell your compiler that these do not cache, the value of this variable. Why? Because we want to read it directly from the main memory so that whenever there are multiple threads running, they can read the latest value that will be from main memory. If it is cached, then the thread might pick up from cache and it might not be the latest updated value. So it's always better to read it from the main memory if you want the data should be available, the latest data should be available to all the threads. So if you want to share any variable in which read and write operation is atomic by implementation, example read and write in an int or a boolean variable, then you can declare them as a volatile variable. Fine. The Java volatile keyword cannot be used with a method or a class, and it can only be used with a variable. Java volatile keyword also guarantees visibility and ordering. After Java 5, write to any volatile variable happens before any read into the volatile variable. By the way, the use of volatile keyword also prevents compiler or JVM from reordering of code or moving away them from synchronization barrier. Okay, so this is again a usefulness of volatile keyword. Okay guys, so this was about a volatile keyword. Now let's move forward. Okay, so we have another question which is what is the difference between cyclic barrier and countdown latch? Well, cyclic barrier, if you say like the purpose of for both of them is quite similar, but when we say cyclic barrier, it is reusable. That is, if the count goes to 0, then you can relift it or reuse it again. But in countdown latch, when the count goes to 0, it cannot be reused. So that is a major difference between cyclic barrier and countdown latch. Fine. Now write a program which will result in a deadlock and how you will fix it. So firstly, let's see a program that will result in a deadlock. So you see in this program we are having a class deadlock demo. Then we are having method 1. So this method 1 is actually having a synchronized block, and this synchronized block is actually acquiring a lock on a string class. Fine. Within this, lock of a string class, it is acquiring a lock on another class or an object of another class, which is integer. So it is acquiring a lock inside us. After acquiring a string lock, it is acquiring a lock on an integer object. So this is what's happening in method 1, that this method requests for two locks, firstly for string and then is for integer. Okay. Now let's see this method. Now this method also requests for the same two lock but exactly in opposite order. That is first integer and then string. Now this creates a potential deadlock. If one wants a thread to hold a string lock and other holds the integer lock, then they wait for each other forever and they won't get their locks. Okay, so this will result into deadlock. So this is how you can create a deadlock. Now, how to prevent it? Well, the answer for prevention is that always make sure that you are implementing or acquiring the logs in a way that the logs are not dependent on each other. So if we just reverse the order of log in this method too, that is we put the string log firstly and then inside that let's put the integer log, then the deadlock will be resolved. Okay, so this is a solution of this deadlock situation. So I hope so you got the answer for that. So okay guys, that was about this tutorial and I hope so that you enjoyed running the QA session as well. So this was about the multi-threading. Now let's meet in the next tutorial. Thank you.